Here are your video notes for lesson 5.6, and it will be on transformations. The first thing we will do here is to define what is a transformation, and a transformation is an operation that changes a figure's position or size. And what you get, or the results of a transformation, are called an image. And that would be an image of the first figure that you started with. We have some mathematical rules for doing these transformations. They are as follows, and we will take a look at three of these with three examples now, show you working with these. The first one says you're going to start with the points x and y, and you're going to change x by either adding or subtracting a value a onto what x is, and y you're going to change by either adding or subtracting the value of b onto the y values. And to show you what this looks like, we'll jump ahead. We'll take a simple shape such as a triangle, which just has the three coordinates a, b, and c. And if we make up a rule for this, we're going to say the point x is going to become x minus 2, and the point y is going to become y plus 3. So now we need to look up and see what are our coordinates for A, what are our coordinates for B, and what are our coordinates for C. A is the point located right here, which from the origin you're going over 1 to the right and down 1, giving you the coordinates positive 1, negative 1. B being the point that's located out here, that is at 4, going over to the right and down 2, so it's 4, negative 2, and the point C down there is going to be at 2, negative 2. If we go through now and look at taking each one of these coordinates, the first part of the rule says whatever x is, and x being the first values, that's the 1, the 4, and the 2, we're going to subtract 2 from those numbers. Now the 1 minus 2 will give us negative 1, the 4 minus 2 is going to give us 2, and this 2 minus the 2 is going to give us 0. If we now look at the rule for the y points, it says we're supposed to take y and add 3 to it. So the y points being these, it'll be the negative 1 plus 3, which is going to give us 2. The negative 2 plus 3 is going to give us 1, and the negative 2 plus 3, and I actually have that as the wrong point, that's supposed to be negative 3. Negative 3 plus 3 is going to give us 0. If we go through and plot these new points, the new points are called A, and this little mark is read off as prime. So we've translated point A, that arrow means we've translated it, to the point A prime, we've translated B to B prime, we've translated C to C prime. If we plot these points, first of all, negative 1, 2 is located here. Here's our new point A prime. Our new point B prime is located at 2, 1, which is here. There's B prime, and C prime is located at the point 0, 0, which that's that. And if we draw this shape in, we should see what we've done is we've changed the position of triangle ABC, and it's now triangle A prime, B prime, C prime. This type of a transformation is called a translation. And it's most simply thought of as just a slide. You'd be able to take the triangle ABC here, if I can click on it in the right spot to select it, and show what we're really doing is this has been moved over to the left 1, 2 units. After it got moved over 2 units to the left, it got moved up 1, 2, 3 units up, and that's how we got the resulting figure. The key thing about this is to understand right here that is going to end up causing it to move 2 units to the left. Notice that's what got done to the x-axis, and the x-axis is the one that goes left and right. So whatever's being done to the x value will actually control left and right, and what's actually done to the y value, that's where we have y plus 3 here, the plus 3 caused it to go up 3 units because the y-axis is the axis that's going up and down, so the plus 3 moved it up 3 units. If we go back to over here, we now could write in, this rule is going to cause what type of transformation? It's a translation. Or in other words, a slide. We slid the unit to the left 2 and up 3. If we drop down and, for example 2, we check out this rule of having x and negative y, we'll see what that looks like as far as to reflect our object. So if we write that in, we have x, negative y. What this really says is, if you notice how we have x, and by the way, I already have the coordinates written in, it's the same shape as we had in example 1. X is here, we don't change x in any way, so the 1, the 4, and the 2 are just going to move over here as 1, 4, and 2. And the part of the y value, it says negative y, which means you're going to make them the opposites, or you're going to multiply them times negative 1. This negative 1 times negative 1 will turn into positive 1, or the opposite of negative 1. The next one will be the opposite of 2, which is positive 2. The next one is negative 3. The opposite of negative 3 would be positive 3. And if we now were to go through and plot these coordinates to get our new image, which once again is a prime, b prime, c prime, we're going to plot a point at 1, positive 1. Call that a prime. B prime is going to be at 4, 2, which is out there. And C prime is going to be at 2, 3, which is right there. And if you connect these, you should see the resulting shape. That type of translation is going to be called a reflection, because what it's doing is it is resulting in a mirror image. And if you want to think about this in terms of a mirror, point A, which is right here, if you go straight to the mirror, its image should be straight back. The distance that it is away from the mirror should be equal to the distance that the image would be behind the mirror. B goes straight back into the mirror. It's 2 units away here. It's 2 units away up there. C goes straight back to the mirror. It's 3 units away here. It goes back 1, 2, 3 units there. So that's how that ends up being that. The easier way, really, in my mind anyway, to think about all this is you could also refer to a reflection. In more simple terms, it is a flip. And in the case of what we are looking at right now, the flip that you have here, this has been flipped, kind of picked up and reflected or flipped across the x-axis. So the rule that we're looking at here gives us a reflection across the x-axis. If we go back to the front side of your notes template, what you should be writing in for what does this rule do, it will cause a reflection across the x-axis. And this rule right here would also cause a reflection, but instead of it being across the x-axis, this will be a reflection across the y-axis. Alright, so for example 3 now, if we drop down here and we check out what a rule like that one will do, on the back side of your paper you have room for this last example. Once again, we have the coordinates of A, B, and C already written in. And if we're looking at the rule, we're going to take x and y and turn it into y negative x. Now what this is really saying is that the y values that over here are second, they are going to become first. So whatever y is at -1, -2, and -3, we are going to move those to the first position here, and we will have -1, -2, -3. And then for the x values, they were the first values. The x values are now the second values. If we move them to the second position, we will have 1, 4, and 2. But not only do they change to that, but they will also change to their opposites. So it was a +1. This is going to be a -1. The opposite of the 4 will be -4, and the opposite of 2 will be -2. And if we go through and plot our new points for this, -1, 1 will be here. Plotting B prime, we want to go to -2, -4 and plot B prime. And for plotting C, we want to go to the point -3, -2. That's our C prime. If we connect them now, our new shape is this. And if you can't tell how that has happened, we've actually turned or twisted it, and the official name for turning is going to be a rotation. Okay, and rotations can be a little tricky. If I select the triangle, taken like this side right here and rotated it down to there, which would be to turn it 90 degrees. If you're having a hard time visualizing what I'm saying, let me select the triangle here. If I take this and select this, you can actually see me turn this so that we have gone over to here, and that's 90 degrees in what, a clockwise or a counterclockwise direction. That would be going clockwise, the same direction the hands move on a clock. If I were to undo what I just did, we actually could show you what would it look like to go counterclockwise. This would be a 90 degrees counterclockwise rotation, and there's a rule that will give you that rotation. And if I undo what I did again, we went back to where we're starting. We could rotate it also not only just 90 degrees, but another 90 would give us a total of 180. That would be a 180 degree rotation that you see over there. And the nice thing about a 190 degree rotation, I just went clockwise, but if I go clockwise and rotate 180 degrees, do you see that it comes out with the same thing? So remember, what we actually did here though was we went 90 degrees counterclockwise. So if we go back to the original sheet as far as our rules, the first rule we have listed here will give us a rotation. All of these will give us rotations. Okay, they all give you a rotation. The top one gives you a rotation of 90 degrees clockwise. The next one gives you a rotation of 90 degrees counterclockwise, meaning the opposite direction that the hands on a clock move. And the bottom one gives you a 180 degree rotation, and you don't have to actually determine whether it's clockwise or clockwise. They result in the same thing. This concludes your video notes.